This is another video tutorial session regarding the IR spectroscopy. Before going to the topic, subscribe my channel. In this video tutorial, we will be talking about the IR spectroscopy, yes, which is also known as the infrared spectroscopy and vibrational spectroscopy also. Why it is so named as vibrational spectroscopy or the infrared spectroscopy? Let's see one by one. Yes, for understanding the structure of unknown chemical compounds, we have different techniques like NMR spectroscopy, mass spectroscopy, X-ray crystallography. This IR spectroscopy gives an idea about the functional groups in association with the main compound or the target molecule. We already know that the IR spectroscopy is also known as a vibrational spectroscopy. Why? Because it involves the vibrations in the compound that is going to analyze. That is the study of absorption of IR radiation by the molecule, which results in the vibrational transitions at many rates, giving rise to the close packed bands. The close packed bands are also called absorption spectrum. Right. Coming to the definition of the IR spectrum. IR spectroscopy or the vibrational spectroscopy is concerned with the study of absorption of IR radiation by the molecule. Yes, which results in the vibrational transitions at many rates, giving rise to the close packed absorption bands called the IR absorption spectrum. It is to be noted that since a change in the vibrational level involves the rotational levels also, yes, the resulting spectra that we obtained is called the vibrational rotational spectra. Various bands will be present in the IR spectrum which will correspond to the characteristic functional groups or the bonds present in the chemical structure. Next, coming to the IR region, where the IR region fall in the electromagnetic spectrum. It can be categorized into the near IR, middle IR and the far IR. Near IR is also known as overtone region and middle IR is also known as vibrational region. Far IR is known as rotational region. This we can see in the wavelength and the wave number also. Coming to the near IR, in the wavelength, it can be said to be 0.8 to 2.5 microns and middle IR is said to be 2.5 to 25 microns. That is said to be in the wavelength, right? Coming to the far IR, it's 25 microns. That we can see in the wave number also. Near IR fall under 12,500 to 4,000 centimeter inverse and middle IR fall under 4,000 to 400 centimeter inverse and far IR fall under 400 to 10 centimeter inverse. This is said to be in the wave number. We already seen that it is the IR radiation by the molecule, which results in the vibrational transformation at many rates, giving rise to the close packed bands. The close packed bands called absorption bands that we have already seen. Yes, the IR ray absorbance by the molecule is said to be the formula absorbance equal to logarithm to the base 10 into 1 by transmittance. The transmittance can be calculated with the formula with this ratio of radiant power transmitted by the sample and the ratio of radiant power transmitted on the sample. That you can remember. If we expose a sample to the IR radiation, the resulting spectra that obtained is like this over percentage transmittance to the wave number. The resulting spectra that we obtained should like this. Depending upon the region that we obtained here, we can estimate the functional group that is present in the particular sample. The next topic that is regarding the principle of infrared spectroscopy. Yes, the principle. Bonds present in atoms or linked with either single bond or double bond or triple bond even. Right. This principle depends on how those molecules behaves when exposed to the IR radiation is simply said to be the principle. If we consider any atom or molecule, they link with bonds, right? Those bonds are not permanent, right? They exhibit different types of motions. They could be vibrate. If we take the C single bond O, this bond is analogous to the springs. The spring may stretch opposite to each other or towards each other, called wagging or stretching. This we can see in the theory of the IR spectroscopy. First we see the principle of the IR spectroscopy. Yes, criteria for a compound to absorb the IR radiation is In general, every molecule exhibits natural frequency of vibration. If we expose a sample with the IR radiation with some frequency, with some dipole moment, there is a change in the natural vibration, frequency of vibration. Then the molecule gives rise to the spectrum called the IR spectrum. There are two types of vibrations that we can see when IR hits the molecule, called stretching or the bending, that we see in the theory session. Coming to this principle, in any molecule it is noted that the atoms or the groups are connected with the bonds, or these bonds are analogous to the springs that are not rigid in nature because of the continuous motion of the molecule. They maintain some vibrations with some frequency is the characteristic to every portion of the molecule called the natural frequency of vibrations. The absorption of the IR radiations causes an excitation of the molecule from the lower to higher vibrational level. Each vibrational level is closely associated with the rotational level. Thus, the obtained spectra that we called as vibrational rotational spectra. Every bond or the portion of molecule or the functional group requires the different frequency for absorption of the IR rays. Right? Hence, a characteristic peak is observed for every function or the part of the molecule. Thus, the IR spectrum is nothing but a fingerprint of a molecule. Right? Here in this diagram, we can observe that CH bending and the CH stretching. CH bending is observed at one wave number and CH stretching is observed at another wave number. Right? CH bending that we can observe at 1340 centimeter inverse and CH stretching is observed at 2850 to 2960 centimeter inverse. Likewise, here also OH bending and the OH stretching is observed at different wave numbers. So that we can say the IR spectra is nothing but a fingerprint of a molecule. That we can say from this diagram. I forgot to say you one thing, that is about compounds that are accompanied by the change in the dipole moment are called infrared active compounds. For example, C double bond O and N single bond H and O single bond H. These exhibit a change in the dipole moment called the infrared active compounds also. There are certain compounds that are not exhibit the change in the dipole moment. Examples of this one are symmetrical alkenes and alkynes. This is regarding the definition and the principle of the IR spectroscopy. Guys, for getting more updates on these videos, please subscribe my channel. Don't forget about this.